Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. In our previous lecture, we learned about the Bronsted-Lowry concept of acids and bases. This concept said that the acid is a proton donor species and the base is the proton acceptor species. So this means that in this concept, substances were identified on the basis of donation or acceptance of proton. However, there were some limitations in this concept, and that limitation was that it cannot explain the behavior of some substances as acids or bases because they don't accept or donate electrons. For example, sulfur dioxide, carbon dioxide, and boron trifluoride, these substances do not accept or donate proton, so therefore we cannot identify them as an acid or as a base. So in order to overcome this limitation, a new concept was proposed, and that concept was the Lewis concept of acids and bases. Now we need to know that what is this concept and how the substances are identified as acids or bases in this concept. This concept was proposed by G.N. Lewis in 1923, and in this concept, substances were identified as acids or bases on the basis of donation and acceptance of the pair of electron. In the Bronsted-Lowry concept, substances were identified on the basis of donation and acceptance of proton. In the Lewis concept, substances are identified as acids or bases on the basis of donation and acceptance of an electron pair. So this concept says that Lewis acid is a species that accept a pair of electrons. For example, in this reaction, HCl is reacting with water molecule to form the chloride ion and the hydronium ion. Now in this example, you may see here that the electron pair has been donated from the oxygen atom to the hydrogen atom in HCl, and after this donation the bond between the H and Cl broke and the HCl has been converted into chloride ion. Now you may see here that when the oxygen atom donated electron pair to the hydrogen atom leaves the HCl molecule by giving its electron to the chlorine atom. Now when it gave electron to the chlorine atom has an additional electron in its valence shell, and because of the presence of this additional electron, chlorine atom got a negative charge and was converted into chloride ion. Now when this hydrogen atom gave its electron to chlorine atom, it has been converted into hydrogen ion or the proton. Now it doesn't have any electron in its valence shell in order to form any bond with other substance. So what would the oxygen do? Oxygen would donate its electron pair. Oxygen oxygen would donate its electron pair to the hydrogen ion, and this donation of electron pair will result in the formation of hydronium ion, and the bond between the oxygen and the hydrogen ion would that be of the coordinate covalent bond. Now since that hydrogen is accepting the pair of electron, so therefore we will consider it that HCl is acting as an acid here because the hydrogen in the HCl is accepting the pair of electron from the oxygen atom of the water molecule. Similarly, in the Lewis base is a species that donates a pair of electron. For example, you have a reaction in which the ammonia reacts with water molecule to form the ammonium ion and the hydroxide ion. Now here the ammonia lone pair present on the nitrogen atom of the ammonia is donating its electron pair to bind with the hydrogen ion. That hydrogen ion will be generated when the bond between the oxygen atom and the hydrogen atom will break. How it will break? That the electron of the hydrogen atom will move towards the oxygen atom. So this means that there is an additional electron on the oxygen atom, so it will result in the creation of a negative charge on the oxygen atom in the hydroxide ion. Now since that hydrogen is left with no electron, it has been converted into hydrogen ion. So the nitrogen atom, by using its lone pair, will form a coordinate covalent bond with this hydrogen ion. Now, and has been converted into ammonium ion. Now see here that since the nitrogen atom is donating its electron pair, so therefore this ammonia will be considered as a Lewis base here. So in this reaction, ammonia is the Lewis base while water is the Lewis acid, because hydrogen atom in the water molecule is accepting the pair of electron from the nitrogen atom in the ammonia molecule.